So a quick recap of the magnetic field, just going over the importance. The magnet, we have a north and south pole. So, and this magnetic field going from north to south. Very important. All over these places that you see. Oh, let me share this. Sure. So this is what we share. So we have a magnet and has a north and south pole. You see, the magnetic field is always from north to south. You really need to keep in your mind. Everywhere you will see that. Outside is from north to south. Okay, just remember that. This is useful for your quiz, for your test. So I could give you a definition for the one of that. You need to understand what is the magnetic material. Maybe you need to know that about ferromagnetics. Ferromagnetics, that could be one of the questions that you need to know, that this is kind of the shape of that. Or you need to know that what is the magnet properties, that all of these regions are aligned. For ferromagnetics, this region is not aligned. You have a region of these dipoles. And for non-magnetic, they are in a random. So one of your question is from these three shapes on your test. I'm going to go back and tell you one more time. But yeah, also that would be something that you need to know. You need to know how to draw this things from north to south. Easy. Um, Now the Oersted laws, important. Using your right hand rule. For example, this is my wire. I want to see what is this direction of the magnetic field. So you take your thumb. This is your wire. You take your wire and you put your thumb in a direction of the, if the current is to the right, you put your thumb to the right across your wire, and your forefinger bending. Your forefinger will tell you the direction of the magnetic field. As you see in this picture, the thumb is in the direction of the wire, the forefinger is bent, and this bending would be the direction of what? Magnetic field. So in front of the wire, the magnetic field go down. At the back of the wire, magnetic field go up. So I just, that would be something like a circle. And you see this circle, right? At the back, it's go up, and in front, it's go down. These are the circle of magnetic field. Any question, you can turn on your mic and talk to me. So again, if you're saying the electron is flowing, you have to use your left hand, but just, I'm not gonna give you a question with the left hand, just assuming you are working with a positive charges, which is the conventional current. Here was another example. If you these are the wire, this is gonna tell you for A means the current going into the page, right? And you're using your right hand. So it would be clockwise if you do it. And for this one, the current going out. So I need to put my thumb like in out of the screen, and forefinger going counterclockwise. You have to try it, unless you won't get it if you don't try. And that would be another example. Now, the magnetic field is given, and you need to find the direction of the current. So this one is kind of, if I have my wire, it would be my forefinger should bend like this. Now my thumb is going to the right for B. This is the right, and for A going to the right, and for B, this is my forefinger going to toward the magnetic field. Now my thumb going to the left. So um, so again, if I put my thumb, if I put my forefinger kind of that, bending like this, okay, then my thumb, you will see that my thumb will be in the direction, that direction. So the current will be that direction. Same thing, forefinger in the direction of the magnetic field. You will see your thumb is here, means this is the direction of the current. Your forefinger here going counterclockwise, then your thumb gonna be out of the page. That would be the direction of the current I. Okay. That was a very quick recap of what was happening in last class. Any question? No? Okay. Now, we're doing 12.4. I believe some of you have question. I'm gonna go and see who's that. Any question? Okay, no, not yet. Okay, so we're doing 12.4, 12.5, which is solenoid, the motor principle. Whenever I'm demonstrating something, I want everyone to try doing this, right? So we need to determine how magnetic field vary for a coiled current carrying conductors, factors that change the magnetic field strength in a coiled current carrying conductor, use the motor principle to predict the direction of an object in a magnetic field. So here we have a coil, okay? So the coil, as you see, we have number of the windings, right? More windings you will see, this produce a stronger magnetic field. We did observe that a wire that carrying current produce magnetic field in like a circle around it, right? If I want to draw that, that would be kind of going up at the back of the wire if using my right hand, and in front of that is magnetic field going down like that. Now, if we have our wire, we get our wire and just wind that with N, number of the windings. So what happens, you will, again, it will produce a magnetic field. Now we want to find what is the direction of this magnetic field. So we have a current, right? As you see, the current is given to you, is going up in front. So all of this little wires that is in front of the solenoid, the current is going up. And of course, because this is going around at the back, you will have your current going down, right? It's kind of a loop, right? It's a circle. So that's why I can show that here. So it makes sense at the back, see, going down, but in front, the current is going up. So knowing that in front, the current is going up, take your forefinger. Forefinger would be the direction of the current. Put your forefinger around this, the direction of the current. Then your thumb will show you the direction of the magnetic field. So your thumb will point to the N side of this magnet. So your thumb will be pointing to N. So that would be N. If the thumb is pointing to N, so the other side, of course, should be S. Got it? Knowing that from outside, it is kind of working like a magnet. Outside, the magnet is like a magnet. The direction of this magnet is kind of from N to S. I told you, right? But look at the inside. Inside, the direction of the magnetic field is from S to N. It makes sense, right? But knowing that direction of the magnetic field, if this is outside the magnet, is going to be from N to the south, and it perfectly works. So I want to give everyone a chance, just 1 minute, to try. Put your hand across like that, a solenoid. and try to figure out this North Pole. Everyone trying? I want everyone to try that. Give you 1 minute. And if you have question, just turn on your mic to talk to me.
Sorry, miss, could you mark me present?
Who's this?
Ratman.
Okay, Rodman. Yeah, give me a second. I'm gonna write down and then go back.
Thank you.
Yeah, here. Rodman present. Okay. Everyone got a chance to do it? If you need more time, just turn on your mic, say no more time, please. I'm gonna move on to the next. Hopefully you try it because that would be one of your questions. When I give you a battery, okay, and you need to tell me the direction of the current from the battery, gonna be from positive, right, to negative, then you will get solenoid and you will be asked what is the in and what is the south, right? So knowing that the in front of the in front current going to be down, at the back going up, put your forefinger down. So your thumb will point it to the north. That would be south. So that is one of the questions I'm going to give you. All right. Make sure you understand what's going on here. Now here is another, sorry. Okay, here is another example. You have a solenoid is winding and you put, of course, some iron medium in the middle to make this magnetic field stronger. So you need to tell me what is the in pole and south pole. So label the north and south poles on a diagram before. So you bend your forefinger in the direction of the current, and your thumb will show or pointing toward N. So that would be N. So the other side gonna be S. Any question?
Miss, so like, does the thumb ever like point to the south instead of the north or no?
Okay, would you please repeat? I didn't hear you well.
Would the thumb ever like point to the south instead of north?
No, you using your right hand rules, right? Right, for if you're using the right hand and it's a positive current, the thumb is always to north. But somehow if the negative charges is moving and you're using your left hand, then your thumb moving to the south. But I'm not gonna make it that complicated. Always, I'm gonna ask you that this current is a conventional current, is a positive charges, okay? If this is positive charges, that's the rule, right hand. And that would be a plus of your battery. That is your negative, right? The current going from plus to negative. So it means the positive charges is moving. Good question though. But always use your right hand when you get this kind of questions. And his thumb is always pointing to the north for me. So here is another example. Label the direction of the current in a diagram. So you have a north and south. So what you do right now, I want everyone to try. Put your thumb, your right hand, put your thumb in a direction of the north, and then put a pencil, make sure that your thumb is in direction of that pencil. Then you tell me what is happening to the current at the back and in front. Is the current at the back going up or down, or in front going up or down? You tell me. Everyone understood what I mean? Okay,
I have a quick
yeah,
question.
sure.
So for the first right-hand rule, will it also will your thumb also always point north for just like the normal wire?
Okay, no, normal wire is different, right? For normal wires, you put your thumb in the direction of what? Current. That would be totally different rule. But here is solenoid, right? This rule is just for solenoid.
Okay, cool. Thank you.
You're welcome. Good question. Thanks for asking and clarifying. I'm sure this question could be better as students. Okay, again, so you put your thumb directing to the North Pole, and then you just put a pencil in your hand. Make sure the thumb is along that pencil. Then you observe your forefinger. Is it going up at the back, going down at the back, and in front? If you bend it, would it go down or up?
Miss, I just have a question.
Sure.
When I'm submitting my quiz, you said that we have to like take a picture, but there's no like place on the form where I can attach like the
No, I didn't say take a picture. Just please record your answer on a piece of paper in case it's not submitted,
Oh,
so I
okay.
can check that. You
Okay.
can send it by email.
Okay, then I'm gonna submit my quiz right now. Can you just check?
Okay, so who's that?
Honey.
Honey, just you need to wait until I just finish that, right? I cannot do
Okay.
that.
Okay, it's fine.
I'm gonna check that and let you know.
Okay.
Okay, any questions? So can one of you tell me what was your result from doing this? Tell me, should the current go down or up for this solenoid in front of that?
This is down.
Okay, so you said down. I'm gonna check. Yes, so putting the thumb in the direction of the um end pole, then I will see that my forefinger going up at the back, and when I bend it, going down in front. So it means this is gonna be the direction of the current. If you follow that at the back, the current go up, but in front it going down. So it means this is here. And if you follow that, it's go down, right? And if I want to connect the battery, so that would be from, because it's from here to here, so that would be positive and here would be negative, right? Any question before I move on? Definitely you will get a battery and say what is the north or south, or you will get the direction of current. Yeah, you get the direction of current, tell me which one is north and which one is south, or you will get the north and south pole and you need to figure out the direction of the current, okay? Definitely, this is one of your multiple choice questions. Definitely. Solenoids, how do you think we can alter magnetic field for a solenoid? So to do that, we can do the followings. Increase the number of turns or windings. The more turns, the more magnetic field created added. So each of those turns give you additional strength to your magnetic field. Increase the current through the wire. Of course, if you increase the current, you will get the stronger magnetic field across the solenoid. Now, next we're going through the motor principles. You have seen when two magnets interact, like North Pole and South Pole, they attract each other. This is from north to south. They just connect that. But when you have a same pole, they repel each other. See this field kind of going and escaping from each other is not connected here, but here they going from north to south, they connected. Now, when they attract, they pull each other with force, right? So the magnetic field can create a force, can apply force on objects. So it has ability to move objects. So it has so many interesting properties. Now, okay, I'm gonna go back. If two magnetic field interact, then what is the conclusion? Two magnetic field interact, so they produce some kind of force. Okay, so I could have two magnets. Each magnet has field, magnetic field, right? And these two magnetic field interact, and this force will be applied. It could be repulsion, it could be attraction. Now, how about when I have a wire and I have a magnet? You have seen that wires, when there is a current inside a wire, the wire produce a magnetic field around itself, right? Will have a magnetic field around the wire. Also, the magnet will create a magnetic field around itself. So two magnetic field, they interact, then there will be a force, attraction or repulsion. There will be a force, right? Now, my job here is to see if there is an external magnetic field around a wire carrying current. What is the direction of the force? Where this wire will be dragged? That's is right hand rule number 3. We had 2 right hand rules so far. I'm gonna just make sure everyone give you a reminder. When we had a current in a wire, so right hand rule, I could predict the direction of the magnetic field. For me, this is the direction of the magnetic field wire. Another things like we had when we have a solenoid. Okay, we have a solenoid and that was in front of this current going up. So the front current going up and back go down. So if I do it, so it will, using the right hand rule again, forefinger across the current, it points to the north. Here is south. And you know, outside this magnet field gonna be from north to south. So again, that was my second. So this was my first. This is my second right hand rule. Now we're going to the third right hand rule. When you have a wire, so you have a magnetic field around the wire, and then you have external magnets, which create a magnetic field. So these two magnetic field interact and there will be force. Now I'm gonna use this right hand rule to find the direction of the force on wire. Okay, follow me. Everyone follow me. Try to use your right hand as I do. Read through that. Open the right hand so that fingers point into direction of magnetic field. Now, someone asked me, what is the direction of the magnetic field? Of course, it's going to be from north to what? South. These external ones. I'm not talking about the magnetic field of this wire. The external magnetic field, which is from north to south, okay? So, again, open right hand. So your fingers, so I'm going to do that. My fingers going into the direction of the magnetic field, which is from north to south. Now I need to rotate my hand so my thumb will be in the direction of what? Current. So current is out of the page. I need to rotate it. Now my finger is into my face, like toward my face, because this is out of the page, right? Now your palm will be in a direction of magnetic force. So I want everyone to try this and tell me, is that your palm is facing to the right or your palm facing to left? One of you please turn on the mic following this instruction. Tell me if your palm facing to the right or left by doing it?
It's to the right, but I also have a question.
It is to the right. Yeah, what's your question? That would be the direction of the force.
How do we know the wire is facing, or is the current is coming out of the?
So this, if you have this circle and that means out of the page.
Uh-huh.
And if you have a like circle like that here, it's going to be into the page.
Oh, okay. Thank you.
You're
Miss, I finished my test.
Thank you. Who's that?
Mehmet Khan.
Okay, Mehmet, you just need to wait until I finish this.
Okay.
All right. So
Miss, wouldn't it be towards the left though? Because you're going into the page.
this is out of the page. This is your thumb getting out of the page. See, this is a dot here.
Oh, I just read that as like a X. That's why.
Okay. What's going on with this plot? Oh. Okay. So move on to the next one. Can you do this one? I'm gonna just so we have this example and the second example and third example. I want everyone to think about this. Determine where the conductor will travel means where is the force. If this is force to the right, of course, moving to right. We did it, right? I'm gonna do it again. So it's from north to south. And, you know, just put your forefinger that way and your thumb out of the page because the out of the page is the direction of the current. So your palm facing to the right. So this is going to be force. This is just what we did. Now this force dragging the wire toward right. Okay. Determine where the conductor will travel. It's going to be right. This one is the one that is different. Now is current going into the page. I want to just take 1 minute, do it, and one of you turn on the mic and tell me the result. Anyone want to tell me the results of your forefinger toward magnetic field. So your forefinger should be from north to south. You need to use your forefinger down. And the thumb going into the page. You rotate your hands. So your thumb going into the page. Then your palm will tell you the direction of the force. Anyone want to tell me the results? Should I do that?
Is it left?
Very good. Yes. So your forefinger, thank you. Your forefinger is down. You just rotate your hand. So your thumb going into the page. Then your palm is facing to the left. Very good. Now this is another example, but the force is given. And you need to find the direction of the external magnetic field. So what I do, I'm going to do that. You know, the palm is facing the force. I'm just rotate my hand, make sure the palm is facing to the direction of the force. And I know that my thumb need to get out of the page, right? I rotate it. My thumb is now out of the page. Now, my forefinger gonna be toward the magnetic field. I know the magnetic field gonna be from north to south. So the upper one should be north and the lower one should be south, okay? That would be north and that would be south. Any question?
Miss, can